Thank you for coming to this late session. I know it's the end of the day, so it takes quite a bit of courage to get to that last session. My name's John Ferguson Smart, and I help organisations work better. I help organisations introduce practices like behaviour driven development, XP practices, scaling agile to some extent. And today I'm going to talk about team engagement. Who came up with this title? What a wishy-washy title, eh? Go, who came up with... Oh, that'd be me. So, it looks like one of those wishy-washy agile talks, doesn't it? I'm sorry, I don't do wishy-washy agile talks. I tried once, but didn't really work out. So, there will be some hardcore practical stuff in this talk, despite the wishy-washy title. But let's start off with something a little bit more fun. My clicker doesn't work. So, back around the time when I was born, 1969, this was before internet, so really, really old. There was this lady called Margaret Hamilton who wrote a small piece of software to pilot the spacecraft going to the moon in the MIT laboratories. That's Margaret here with the source code that took the Apollo project rockets to the moon. She was actually working on this, what they called the Apollo guidance computer, the AGC, which was pretty highly powered for the time. It had 4K RAM, 72K ROM, K, so 1000, 17 registers. 17, wow. And a 1 meg clock. It's pretty cool stuff, eh? And so that's slightly slower than probably the phones you have in your pockets. It's the notch, about 1,000 times slower. And they recently released the source code for the Apollo project onto GitHub, and there's some really nice stuff in there. So this is the actual source code. This is the software developers of the 60s having a bit of fun. So we've got the burn baby burn routine. What else have we got? We've got, this is a good one. Have you ever introduced a little bit of temporary code and then it sort of ends up in production? And the story about how this code got written is really interesting too, because this was before compilers. This was back in the days of punch cards. I don't know whether any of you have used punch cards. Probably a few. Anyone? No? Yeah? You don't want to admit it? Well, this was actually pretty cool because it was a physical machine that they had to code. So they made a virtual version of the physical machine. So they made VMs before VMware. And the way it worked was you had these little coils, these sort of donut-shaped objects, and you passed wires in and out. They weaved in and out of the wires. If the wire went through the coil, it was a 1. And if the wire went around the coil, it was a 0. And you had these ladies, because you had to be skilled at weaving to do this. It was basically weaving. And the term LOL, you may have heard of the term LOL, which dates from the 1960s and means little old lady. Because that was Margaret Hamilton's name for the ladies who did this stuff. And so the question is, how did these teams that were basically, they were inventing everything. There were no compilers, no software engineering didn't exist. They were literally making it up as they go along. They were just maths and engineering graduates from MIT, so probably reasonably smart. But how did they manage to write software to take people to the moon? So in the time, they didn't have Agile, they didn't have Scrum Masters, they didn't even have project managers, really. But what they did have is a deep and clear vision of where they were actually going to and what they were trying to achieve. And that that vision was really what got them through. And the thing that was most important about this, they were basically told, do whatever you need to do and make it happen. So more recently, there's a guy called David Market who wrote a book called Turn This Ship Around, which is all about getting back to that state of enabling teams to do what you need to do and make it happen. Empowering teams, if you like. And this was how they did things back in the day. They trusted the teams to get the job done, and they did get the job done. Almost no one died. But what I want to talk about today in the context of this is one word that I take out of this story, and is that they were engaged teams. They were really passionate about what they were doing. They knew they had a clear vision. They knew they were making a difference, and they were very, very driven. And so I'm going to talk about how this idea of being engaged relates to the sort of work we do. And I want to talk about two aspects of it. So this ties into Google studies on psychological safety and a whole lot of other interesting cognitive bias topics that I could talk for ages on, but I won't, because I've got some cool tricks that I want to show you. But if you want to hear about the cognitive bias, come and ask me later on. What I do want to talk about is this idea of engaging. And often people say, John, you're always saying, why you're talking about the teams, they need to be engaged. When do they need to be engaged? I mean, when the testers get to UAT, is that when they get engaged? And so I generally say, well, a little bit earlier maybe, just a notch. Basically, we want the entire team engaged right from the start, and so that's agile, yeah? Basically. That's agile in your typical large organisation. That's totally how agile works, isn't it? You might detect a slight note of sarcasm. Or is it more like this? In fact, in a lot of organisations, even if we say we're doing agile, we're actually doing management practices which date from the 19th century. They're management practices where people do tasks in a very specific order with specific specialities, and they do the same task over and over again, just like in a factory. That all comes from this mentality of you have a thinker and then a whole lot of doers. And the thinkers decide what needs to be done, and the doers do the stuff. I mean, it dates back when I learnt computer science back in the 90s. There were these roles about you had your programmers, your developers, and then you had the system analysts who were a notch above the developers. They could tell what the developers what to do. They did the thinking. The developers merely typed the code and so forth. And in David Market, who I talked about earlier, he talks about the idea of red work and blue work. Red work is where you do the thinking, and blue work is where you do the doing. And it turns out this idea, this Taylorian approach, it does actually work in some cases. Works for pyramids, works for irrigation systems, works for large walls. Anyone building a large wall or a pyramid? Not so much for knowledge work. In knowledge work, it's a whole different game. In knowledge work, we don't want to think for people. We want to get people to think for themselves. So we're all thinkers and doers. That's the goal. That's what we want to get to, yeah? You can't be thinking for other people, otherwise you get overloaded. And with the complexity of the domains we work in and the technologies we use, a single person cannot possibly know everything, so you can't expect any manager or any team lead to know what everyone else has to do. So we need to get out of this model. And so if you're doing Scrum, you're going to say, yeah, well, Oh, good, I'm doing Scrum. Scrum solves this problem for me, right? Well, unless you can say, well, we're an anarcho-syndicalist commune, and you take turns every second week or so to change executive officers, then you can't really say that. Because the way most organisations do Scrum is a little bit different. So in most organisations, we have, in a highly organised Scrum team, we have our BAs who write the stories and give the stories to the developers, and the developers build stuff which goes to the testers, and the testers deliver stuff which works perfectly. Yeah? What could possibly go wrong? Does anyone relate to this? Is this the way your teams work? Yeah? There's a great story. I don't know whether anyone has read Jeff Patton's user story mapping. There's a great story where he talks about one time when a manager came to him and said, Jeff, I need you to make some changes. I need you to do this, implement this feature. And so Jeff goes, yeah, well, that's fine. Can you tell me a little about what the problem is that you're trying to solve? And so she says, well, they're the requirements, just do them. And he says, well, that's great, but could you just tell me a little bit about the context and about what we're trying to achieve and how it fits in with everything else? And so she looks at him as if he's stupid and says, Jeff, they're the requirements. And then he says, well, it was at that moment that I learnt that the word requirements actually means shut up. And so this is the problem with this model, where we have a huge potential for rework, and we have even a bigger potential for misinterpretation. Often what happens in this model is you can have huge chunks of work being done that are actually not needed. Do you know the easiest code to maintain is the code that you never write? And if you're writing a whole lot of features that aren't actually useful, that's a lot of time that you could be on the beach or in the mall or doing whatever you do when you're not coding. It turns out that they've done a couple of studies. I've seen this on internal studies and a public study somewhere, where they found that 50% of the code that you write in any large application is never actually executed in production. 50%. 50%. So it'd be kind of nice to avoid that. Because what we're really doing is waterfall. Yeah? We're basically doing mini waterfall, water scrumfall if you like. And behaviour-driven development, who's familiar with behaviour-driven development? A few people? So do you understand how behaviour-driven development solves this problem? Here's the way I describe behaviour-driven development. That's in several phases. The first phase is illustrate. Illustrate is where we take the next most important thing that needs doing. We work through concrete examples, we study these examples, we find counter examples, we look for rules, and we understand what we need to do. You notice everyone's here. There's a BA, there's a business person, there's a product owner, a developer, tester, everyone. Once we've got an idea of what those examples are, we go into the formulate phase. So first illustrate, then formulate. Illustrate and formulate are separate phases. So formulate, if we're using Cucumber, we'll write given, when, thens. If we're using Concordian or Fitness, we'll write tables or some other more formal format, but we want something that we can turn into an executable form. Then we automate it. We wire it up and we drive our production code. We build the production code. Somewhere in between the automate and the validate phase, some magic happens and some developers do some work, and we get all our tests passing, and we know that the requirements that we originally asked for have been built, so we're ready to demonstrate. So that's BDD in a nutshell, at a Scrum level. But did you know that behaviour-driven development also applies at other levels other than within a Scrum? There are actually at least 3 levels, 3 circles of BDD, and it's at different levels where it forces you to engage with different people within the team to produce better software. The cycle we just saw, the illustrate, formulate, automate, validate, demonstrate, we could call it tactical BDD. It's what happens in a typical Scrum cadence. So you're doing maybe a feature, well, you'll do a cycle of a day or 2 or 3, or it might last the whole sprint, but not much longer. When you implement one particular acceptance criteria, you'll drill down and you'll do TDD. You'll drive your code from your acceptance criteria and do what you need to do to make it work. And that may involve writing unit tests that drive your detailed design to make the acceptance criteria work. So you do these little circles inside. But what you can also have is a larger scale, a larger circle, which happens at a cadence of maybe every 3-4 sprints, or every milestone, or every large release. Well, you're doing the same thing. You're doing your illustrate, formulate, automate, because a subset of the acceptance criteria get passed into the tactical BDD, validate, demonstrate. And this cycle happens at a more strategic level. So you do this discovery process first at a strategic level to get maybe a 6 to 8 week vision of where you're going. Then you drill down at a lower level, and we'll see there's no need to assume that you can know everything 3 months in advance. So you've got this cycle where you keep going every 2 weeks or so to keep track of where you're at. We'll see that shortly. So if we think of this outer circle, we've got some people that we'll call the value hunters who are looking for the next great thing that needs building. And that goes into our illustrate phase where we have what we call the 3 Amigos. Who's heard of the 3 Amigos? How many people are in the 3 Amigos? Trick question. It's 3, where 3 is a number between 3 and 7. So this is the phase where you get people from the team with different perspectives together. So that's the important thing. It's different perspectives, not different roles, not different people. Different perspectives. And they'll use techniques like feature mapping, which I'll show you shortly, or example mapping to understand the problem we're trying to solve. And then we have the Gherkin gang. Again, we're collaborating, we're getting people engaged. You don't need so many people to do the Gherkin gang. So Gherkin gang could be Concordia, it could be fitness, but you're formulating, you're turning your examples into a more executable form. That, incidentally, this happens before your sprint planning, if you do sprint planning. So your executable specifications go into your sprint planning. And if you're into estimating, that gives you a really good idea of what you need to estimate. If you do this really well, you suddenly realise that you no longer need to estimate. Then we have the Cucumber Club who do the actual automation. We make that pass by building the code. Now, the beautiful thing here is when you get developers and testers pairing on the production code and the automation code. It streamlines things enormously. The big trap is when you do the automation after the production code. And the big breakthrough is when you inverse that, where you do the automation before you do the actual production code. That's a bit of a mindset shift, but it's really, really powerful, and it opens the doors to a whole lot of streamlining of the development practices. Then we get our demonstrate, we can deliver something that actually works. So far, so good. So now what I'd like to show you in a little bit more detail is this 3 Amigos section. I want to show you a technique that you may not have come across before called feature mapping. Who has used or seen or heard of feature mapping? A few people? Feature mapping is really cool. I find it really, really valuable for certain types of problems, which are pretty much all the problems I work with at the moment. This is a real feature mapping exercise. And so here I'll walk you through an example. I think it's easier to show you an example of what feature mapping is than to walk you through the theory. And the theory, in workshops, I spend the whole day talking about all the subtleties of it, but just to give you the general gist. Imagine we have a story. It's about delegating a task. So we've got a supervisor who needs to delegate some tasks to some other employee. So we start off with a concrete example. Always start off with what I call an anchoring narrative, and a story of what we're trying to do, a real concrete story. So I've got Sally, who's assigned a high priority review task for a suspicious transaction. She knows she won't be able to complete it today, so she delegates to her colleague Doug. Doug sees the review task appear in his list, and Sally sees the task appear in the pending others list. So we take our story, and in a feature mapping session, we start with an example. The example is the one where Sally delegates a review task to Doug. So far, it's a little bit like example mapping. Then we break out the example and figure out what steps go into that example. So here we're looking at a narrative flow. It'd probably be a user interaction type story. There are other cases where you do this for data transformation or for more pure business rules where you're talking about inputs and outputs, but it's the same principle. So we have the first step, Sally is assigned a high priority task. She assigns the task to Doug, and then we have consequences. Now, consequences are different from steps. Consequences are the way we talk about the outcomes we're trying to achieve. And the reason we label them as consequences is they play a really important role when we're breaking out the requirements later on. So our first consequence is that the task should be visible in Doug's list. Second one, it should not appear in Sally's list. And the third one is it should be in Sally's pending others list. So far, so good. So now we have a signal flow. And then it gets interesting because we start to ask questions. Now, the thing that we do with feature mapping is it is a way of encouraging people to query, to interrogate a requirement, to take it to pieces, to cross-examine a requirement, if you like. And that's the power of it. It structures your requirements discovery sessions really, really well. It forces people to think of lots of different variations. It forces people to try and come up with edge cases or things that they hadn't considered before. And we might have a question like, okay, that's fine, but what if Doug isn't authorised to handle this particular task? Okay, so we need a rule. The rule is that you can only delegate to authorised tasks. And for each rule, we need an example. The example is the one where Sally delegates a task to Indira, who hasn't got the right or authorisation for this particular type of task. So she assigns the task. She gets assigned the task. Indira is not authorised, so when Sally tries, the consequence is that Indira is not in the list. And then we might come up with other questions. So we keep on with these questions until we get we're reasonably confident that we've covered the pretty much all of the story. Now, it can be a story, it can be an epic, it can be an entire application. Because the really cool thing about feature mapping is that it actually works at multiple levels. So this is a real-world example of a 3-month chunk of work expressed as a feature map that we did in about 45 minutes. Because feature maps are fractal. They're multi-level. We can have a feature map which is a story. And sorry about this. Yep, there we go. We have a feature map which is a story. Now, if you're mapping a story within a sprint, then each row can be an acceptance criteria. And if you've done any gherkin, if you've done any cucumber, if you read through one of those rows, what does it look like? Given when then. This maps directly to a given when then structure. And when you do feature mapping at a story level, you don't get the given when thens that you see sometimes done as test scripts, where you have given the user is logged in and the user clicks on this button, the user clicks on this button, and about 50 lines later, then the user does something else and the user clicks on this button, and it keeps going and going and going. You have really nice, concise, focused Gherkin, really nice, well-written Gherkin scenarios. So it's a very smooth transition to writing good Gherkin. People who start with feature maps, the whole swathe of anti-patterns, of BDD anti-patterns that get totally skipped, which is really nice. But if you look at this at a higher level, if this was sort of an epic-sized feature, because a feature is basically something that delivers value, you don't care how big it is. A feature enables the customer to do something useful that they couldn't do yesterday. Now that might take a day to build, it might take a month. It's not the concern of the feature how big it is, it's the concern of the feature how much value it delivers. Not like a story. A story is a unit of work. A story is just something that you use to organise your work. Users don't care about stories. Users don't care what order you built something in. They only care that you delivered something useful. So users are interested in features, not stories. That's a slight aside just to explain what I mean by features. So when we have a larger feature, these rows, each row might be a story. And the goals are the consequences. Or we might have something bigger where each consequence is a story. So you might think, oh, but each task should be a story. What would happen if each task, each step, we did each step as a story? Would they be good stories? A story that a Sally can be assigned a task, a story that Sally can assign a task to Doug. If we don't have the consequence, it's not much of a story. The value of a story is in the consequence. So this helps people write well-structured stories. And it also helps people break it out. We've got this top one with 3 consequences, 3 different outcomes. We could split that up into fine slices, elephant carpaccio and so forth, where we start with, okay, let's try and just get the task appearing in Doug's list. We won't worry about anything else. And then the next slice, we'll try and get it disappearing from Sally's list as well. Then we'll try and get it appear. We'll do this pending others list. So this is a really powerful way of splitting up and organising your stories as well. So yeah, I really like feature mapping. It's very cool. Now we come to the second topic that I wanted to talk about, and this is a little bit different to what we were talking about earlier. This is about what happens when you've got your team really engaged and they're working really well together, but you've got these other guys over here you have to work with sometimes, and you've got these guys over, this team over here who's building something for you, and you have to coordinate with them. How do you handle that? I mean, you're agile. You don't have to worry about these guys. Because in fact, it's fairly well established that there's an ideal size for teams, and the size is about 6. That's also the ideal size for meetings. Beyond that, productivity starts to drop off quite dramatically. I once did a 3 Amigos workshop, and I said, okay, everybody who's interested in, who's concerned by this story, we'll be working on it. Come to such and such a room at 11 o'clock, and we'll do a 3 Amigos session. And I rock up to the room. There's 18 people in the room. I think they'd missed the 3 bit. There was a subtlety there they'd missed, but they were all Amigos, that's for sure. There is an optimal size, because the challenge with teams is not the number of people in the team, but the number of relationships that have to be maintained, where Brooks' law comes from. You can't just pile people into a project and expect them to be more productive. The output of a team is based on the relationships, not just on the individuals. And so how can we engage with multiple teams if we've got such a small optimal group size and we still need to coordinate? I mean, you've got the scrummers approach, where You get Scrum Masters who all get together and have a bit of a chat. You've got the SAFE approach where you get 150 people in a room and have a really productive meeting. Why are people laughing? Turns out there's another approach, there's another way, which comes from, this particular approach comes from X-Scale, which is a set of scaling patterns, or descaling patterns as they're called, that are quite interesting, and this is one of them. It actually comes from the Iroquois Indians, who were one of the major Indian powers, or group of nations, before European settlement. And they had a really interesting system of governance. Their villages were built around longhouses. And in each longhouse, you'd have families who were related by matriarchal connections. So you'd have groups of families within the longhouse. And when they had to make decisions, they'd do it democratically. Each family would basically send a delegate, choose someone who would represent the family, and they'd get together and have a discussion and then come to an agreement. And then that person would go back to the family and make sure that everybody was happy with it. And that had to be by consensus. And that's how they dealt with issues that related to the longhouse. So what happened in the longhouse stays in the longhouse. But a village, an Iroquois village, is made up of several longhouses, well, quite a few, varying from half a dozen to, I think the maximum was, villages you could get 2,000-3,000 people in a village. So it could be quite big. The Europeans called them castles because they were surrounded by a wooden palisade. And within a village, they had the same system of governance. When they had to decide matters relating to the village, each longhouse would choose a delegate. It was actually the oldest woman in the longhouse who had a particular role, the clan mother, who would choose someone to go and be the delegate. And they would make decisions and go back, and it would have to be ratified in the longhouse for it to be agreed. So the longhouses were autonomous, but the villages coordinated on anything that was related to the villages. And then within a tribe, so a tribe was made up of villages. And how do you think the tribes coordinated? How do you think the villages worked together? They had councils where each village would send delegates. And they'd have to come to an agreement and get it ratified by the village. And this also worked at the nation level. So there were originally 5 nations, later on there were 6 nations. And they did the same thing. They had a system of councils, and this was more to do with international, well, at the time, relationships between the different nations or with other nations. So the Seneca were always being attacked by the tribes to the west. So the central nations promised to support the Seneca in exchange for the Seneca looking after the western borders. They used to make treaties like this. So the idea of treaties is really interesting because treaties would happen between villages or between longhouses or between nations. You didn't have a chief at the top telling everyone what to do. All of the coordination was done at the level it needed to be done through these councils. So at the councils, they would decide, your young'uns are going and hunting all the buffalo. It's a bit of a pain. They're our buffalo. Okay, we'll come to some sort of agreement. And they'd come to an agreement between the 2 tribes or the 2 villages. And it turns out we can do the same thing in our Agile projects. Would you like to see a concrete example of what I mean? Here's a sort of semi-real example. We've got one team who are working on a data lake application. Data lake is basically you dump all your data there and hope that later on you can get something useful out of it. Then we have another team which has a surveillance application. They need data from the data lake. But we also have another team, a regulatory team, which also needs data from the data lake. And this is all happening at the same time. You haven't got time to build a whole set of APIs in the data lake and publish them and hope that they match what the surveillance team needs and also match what the regulatory team needs. It all happens, has to happen at the same time. And you can't have a data architect going off and designing a perfect schema that will suit everyone, because we all know that doesn't work. So the way we coordinate these is we have what we call Bdd Council Meetings. Now this is different from a Scrum of Scrums where you have a Scrum Master. So remember I said the Bdd 3 Amigos, you had typically developers, testers, product owners, BAs and so forth. You have different roles coming together to present different perspectives. At these council meetings, you have different roles, so you're representing different roles and different teams. And they come together to discuss issues that affect the team or how the teams work together. So they may identify, okay, here are the big stories coming up. This particular story, the surveillance team needs some data from the data lake, so they will need to coordinate how they work together. And to do that, we have what we call a Bdd treaty meeting, which is different because here I had 3 teams, but I've had 8 teams in these Bdd council meetings. They can get quite big. If you've got lots of teams and they all need to coordinate, you can have lots of people present. And you might also have DevOps people present, or marketing people present, people who are sort of looking at the overall structure or the overall program. But this treaty is just between the 2 teams that need to coordinate their work. And so they will come up with a treaty. And the treaty, one of the best ways to do the treaty is in the form of acceptance criteria. So you define Bdd acceptance criteria that are basically executable specifications. So I will give you a set of executable specifications that will demonstrate what I need, and if you can make them work, then I'll be happy. And that's my guarantee that you're going to produce something that I can work with. A bit like contract-driven development, except you're doing it a very collaborative way. So that's really the key to this sort of collaboration approach that I wanted to share. And I think that means we have some time for some questions. I've actually got through the material faster than I thought, which is kind of cool. So basically, there are 2 themes that I wanted to abord today. It's the idea that you want to be engaging early. You want to get people working together as early as possible and not in a sort of semi-siloed way. And you want to be able to use the same approaches to coordinate your teams, to make sure the teams can work together effectively and not just within the team. So are there any questions? Yes, there's a question up the back.
Yeah, hey, do you think you need as much ceremony as that, like these treaty meetings, things? Do you think it's possible to just have a culture where just talk to each other a lot?
Do you need that much ceremony? Can you get away with less ceremony? Yes, you can. Your mileage will vary, though. Sometimes a treaty can just be a note on a card. It's nice to have things written down, though, because I often see with backlog planning, if people don't have a sort of written ratification of what was decided, even if people do communicate a lot, it can get distorted, and you still get those assumptions. So the idea of having the treaties, at least for key agreements, if it's a minor thing or a trivial thing, then sure, conversation is enough. But if it's a major thing like the data format that you're exchanging, and you're not talking to each other all the time, I find it very useful. But you've got a good point that the ceremony is to compensate the fact that you're not working together intimately, that you're not co-located. So these teams might be in different buildings or different countries. And that's where the ceremony is really powerful for that. Yes?
So in our team we tried BDD, and what happened
So how do you avoid things that could be tested at the unit testing level being tested at the acceptance level? Sometimes you can actually have things that are defined as an acceptance criteria tested directly against the code. Sometimes that can actually be useful, but in general, you want to make sure that your acceptance criteria are things that the stakeholders, the product owners, would be interested in. If it's how you transform a column title from spaces to underscore when you transform this data format, maybe the product owner doesn't really care. Maybe the product owner just wants to be alerted when there's a violation of some particular constraint. So maybe that, you discuss it, and then it goes straight into unit testing. So this is where pairing works quite well. When you've got the developers and testers collaborating more closely, they can build up confidence. And if you're writing, if you do things like domain-driven development, and where your code is basically written in business terms, making it much easier to understand what the code actually does. And if you write the unit tests in a way that's readable, then the testers can actually collaborate and understand what the unit tests are testing. So you can get that. It's really for the testers, that you want the testers to be reassured. That's the usual thing I find. The testers want to be confident that you have actually tested those column transformations correctly. So yeah, it's basically the Cucumber scenarios, or the BDD scenarios, should really be focused on the business facing and the living documentation and a few key examples. And then you use collaboration and trust to shift the rest down to unit testing as much as possible. Yes, up the back.
How do you deal with cross-application aspects? Like when we have small teams which all include a delivery architect, and we have things like UX, logging, which kind of technology to use. Is this all funneled through this agreement meeting, or how do you deal with this kind of aspect?
So how do you deal with cross-functional specifications across multiple teams? That's a typical thing where the councils work really well. Where you get, because since you're not just dealing with, say, Scrum Masters, you've actually got developers there who know what their actual concerns are. You'll have developers from different teams. You'll be able to raise those questions and come to agreements and come to some sort of compromise or agreement on what approach to take. So yeah, the council meetings work really well for that. And it's similar to what most people do when you've got lots of teams. It's just the only difference is it's a little bit more formal, and you make sure that there's a cross-representation of people involved. It's not just Scrum Masters. So it's quite easy to implement too. Any other questions? Yes? I'm writing a book. But seriously, I've got the first chapter of that book. If you email me, I can send it to you.
I like the different levels.
It works really nicely. It's very fractal. It's very turtle-like. Turtles all the way down. Any other questions? Okay, well, thank you.